आपण अल्कोहोल्स अँड फिनॉल्स या टॉपिकमध्ये ऑलरेडी डायहायड्रिक अल्कोहोल्स डिटेलमध्ये आपलं डिस्कशन झालं होतं आणि यानंतरचं ट्रायहायड्रिक अल्कोहोलचं आपण डिस्कशन पण सुरुवात केलेली आहे. ऍक्च्युअली द कंपाउंड्स विच कंटेनिंग 3OH ग्रुप इज कॉल्ड ट्रायहायड्रिक अल्कोहोल आणि यामध्ये एक सिंपल एक्झाम्पल आपण डिस्कस करतोय इन डिटेल, ग्लिसरॉल. मग यामध्ये आपण पहिल्यांदा स्टडी केलेला आहे मेथड्स फॉर द प्रिपरेशन ऑफ ग्लिसरॉल. यामध्ये फक्त एकच मेथड आपण डिटेलमध्ये स्टडी केलेली आहे, बाय युजिंग फॅट ऑर ऑइल. यानंतर याच्या फिजिकल प्रॉपर्टी सुद्धा आपण स्टडी केलेल्या आहेत. नाउ लेट अस सी नेक्स्ट पॉइंट रिगार्डिंग द ग्लिसरॉल, chemical reactions of glycerol. That glycerol having 3OH group, and out of that 3OH group, 2 are primary in nature and 1 OH is the secondary. Central OH group is the secondary OH group and remaining 2 are the primary, and therefore this compound shows chemical properties just like primary and secondary monohydric alcohol. Okay, first chemical property, that is reaction with electropositive metal. When that glycerol is treated with the sodium metal, that reaction takes place at room temperature, and in this reaction one of the hydrogen atom from primary OH group, that hydrogen atom is replaced by sodium. It was replaced by sodium, and now there is an evolution of hydrogen gas. That means hydrogen is removed in the form of H2 molecule. Thus there is a formation of monosodium glycerolate. Just there is a replacement of one hydrogen atom from the primary OH group and we get the monosodium glycerolate. Now in the second step, it is react with the another sodium metal, then second hydrogen atom from another primary OH group and we get the disodium glycerolate, and thus in this reaction that hydrogen atom from only primary OH group are replaced by sodium, and here that two primary OH group reacts one after other. Their reactivity is different. First primary OH group reacts easily and therefore first step is carried out at room temperature, but second primary OH group is comparatively less reactive, therefore that reaction is carried out at high temperature. Okay, this is just about the reaction with electropositive metal, and this is the characteristic property of primary OH group. That reaction is only shown by primary alcohol. Okay, now by using this reaction we can conclude that primary OH groups are acidic in nature. Okay, there is a loss of hydrogen, there is removal of hydrogen, hence that reaction shows that acidic nature of primary OH group. Okay, this is about the first one. Now let us see second reaction, reaction with hydrogen halide. Hydrogen halide means HCl, HBr, HR, etc. Let us see first reaction with HCl, means how this glycerol react with HCl. Okay, this is our starting material, glycerol, CH2OH, CHOH, and again CH2OH. Okay, this is example of trihydrate alcohol having 3OH group. Okay, now this glycerol, when treated with HCl, when it is treated with hydrogen chloride, now what happens here? In first step, we get mixture of two products. Okay, here suppose one of the primary OH group is replaced by chlorine, and there is the formation of such product, and this particular compound is called glycerol alpha chlorohydrine. This particular compound is the glycerol alpha chlorohydrine. Alpha means, actually suppose that primary carbon is alpha, then secondary is the beta, and again there is a primary carbon, this is alpha dash, means primary carbons are named as the alpha and alpha dash, and secondary carbon is the beta. Now here OH group from the primary carbon is replaced by chlorine, and there is a formation of glycerol alpha chlorohydrine as a major product. But along with this glycerol alpha chlorohydrine, we get one more product. यामध्ये आणखीन एक कंपाउंड आपल्याला मिळतो. There is one secondary OH also there, and that secondary OH can be replaced by chlorine, and there is a formation of another product. Here that secondary OH is replaced by chlorine, and we get one more compound. Actually, in the first step, we get mixture of these two products. पहिल्या स्टेप मध्ये when glycerol is created with the HCl, we get mixture of these two products. But first product, that is alpha chlorohydrin, is major, जास्त प्रमाणात सापडतो, and that second is the minor. Now what should be the name of second one? Secondचं नाव काय असेल? Chlorine is present on the beta carbon. Therefore, it is glycerol beta chlorohydrin. Now, that two products may be further undergo reaction. Suppose we are using excess of HCl. Then what happens here? Here that first product again react with the HCl. त्याची पुन्हा reaction HCl बरोबर होते. And in this reaction, that one more primary OH group, यामधला second जो primary OH group आहे, that OH is also replaced by chlorine. तो सुद्धा क्लोरीन ने रिप्लेस होतो, and we get the dichlorohydrin. We get the dichlorohydrin. What should be the name? Yes, glycerol alpha dash. Glycerol alpha dash dichlorohydrin. Okay, this is again major. Okay, now second possibility here. This particular beta chlorohydrin maybe react with the HCl. याची सुद्धा HCl बरोबर reaction होऊ शकते. And here one primary OH group is replaced by chlorine, and there is again formation of dichlorohydrin. इथे सुद्धा dichlorohydrin तयार होतो if we are using excess of HCl. But what should be the name of second compound? Yes, it is glycerol alpha beta dichlorohydrin, and this is minor. Okay, thus when glycerol react with HCl, in first step we get mixture of alpha chlorohydrin and beta chlorohydrin. Then if we are using excess of HCl, then in the second case we get the alpha beta dichlorohydrin. Okay, this is about the reaction with HCl. Means we are discussing about how actually OH groups are replaced by chlorine. This is simple substitution reaction, and we get corresponding chlorohydrin. Now let us see one more example. Hydrogen iodide. Comparatively, that Hi is more reactive than HCl, and therefore it reacts with the glycerol in some different manner, and therefore we will see how that Hi react with the glycerol. This is very interesting reaction, how that glycerol react with the Hi. Okay, this is our glycerol molecule. Yes, example of trihydric alcohol, also called as triol, having 3 OH groups. 2 OH groups are primary, 1 OH group is the secondary. Now this glycerol, when it reacted with the Hi, what happens here? This Hi is more reactive, and therefore all the 3 OH groups are replaced by iodine. In the first step, all the 3 OH groups are replaced by iodine. We get 1, 2, 3 triiodopropane, but it is comparatively unstable because 3 iodines are successively present, and therefore it is comparatively unstable. Hence, I have shown that molecule in the square bracket. Unstable असल्यामुळे काय होतं? It loses to iodine. त्यामधून 2 iodine बाहेर पडतात. मग iodine कसे बाहेर पडतील बघा. Here this iodine and this iodine, there is an elimination reaction. म्हणजे 2 successive carbon वरून, 2 neighboring carbon वरून 2 iodine बाहेर पडतात. Double bond appears in between that 2 carbon. This is example of elimination reaction. And there is the formation of new molecule, and this is called allyl iodide. Actually, this particular group is called allyl group, and hence name is allyl iodide. Okay, and thus there is a formation of allyl iodide. Now this allyl iodide, can we further react with the excess of Hi? If there is excess of Hi, what should be the possibility? In allyl iodide, there is a carbon double bond carbon. There is a C double bond C, and therefore this Hi adds across the C double bond C. या Hi ची addition या C double bond C ला होते. Hydrogen adds to one carbon, iodine adds to another carbon, but this addition takes place according to the Markovnikov's rule. Now, what is the Markovnikov's rule? According to Markovnikov's rule, negatively charged ion adds to this carbon which carrying less number of hydrogen atom, and therefore iodine atom adds to that carbon central carbon which having less number of hydrogen atom. This is Markovnikov's rule. While hydrogen atom adds to that terminal carbon, and we get the addition product. Now what should be the name of compound? Yes, it is. This is 1,2-diiodopropane. Very simple compound. Okay, but this 1,2-diiodopropane again it is unstable. because two iodines are present on the successive carbon, and therefore this molecule again undergo elimination. That iodine atoms from the successive carbon are removed as a I2, and double bond appears in between that two carbon, and there is a formation of such compound CH3 CH double bond CH2. Now what is the name of this compound? Yes, it is propene. But that propene further react with the one molecule of HI. Addition of HI takes place across the C double bond C. Here also addition is according to the Markovnikov's rule. Negative part adds to that carbon which having less number of hydrogen atoms. Therefore, it iodine adds to this central carbon, hydrogen adds to terminal carbon, and we get the addition product. And there is a formation of 2-idopropane किंवा आपण त्याला आयसोप्रोपिल आयोडाइड असं म्हणतो. And this is the interesting reaction of HI with glycerol. Glycerol when it reacted with the HI. In first step, what happens? All the three OH groups are replaced by iodine. Okay, and there is a loss of water molecule actually, and we get the 1,2,3 triiodopropane. Here iodines are present on the successive carbon. Therefore, comparatively, it is less stable. Now, this molecule undergo elimination, and we get the allyl iodide. That allyl iodide further react with the excess of HI. Again, addition of HI takes place across the C double bond C. Here, this addition is according to Markovnikov's rule, and we get the 1,2-diiodopropane. But in this compound also, there are two iodine present on the successive carbon. Hence, again, it undergo elimination. There is a loss of that two iodine, and we get the propene. Okay. Now, this propene further react with the excess of HI. Then again, HI adds across the C double bond C. Here also addition is according to Markovnikov's rule, and thus there is a formation of isopropyl iodide किंवा आपण त्याला 2-idopropane असंही म्हणतो. Okay, this is just about the reaction with hydrogen iodide. Now let us see some more reaction. यामधल्या आणखी interesting reaction आपण बघूया. How that glycerol react with the HNO3 in presence of concentrated H₂SO4. Okay, suppose glycerol is reacted with the nitric acid, concentrated nitric acid, and that reaction is carried out in presence of concentrated sulfuric acid. Now what happens? That glycerol undergo nitration. Here, hydrogen atom from the OH group is replaced by NO2. Similarly, that second hydrogen and third hydrogen, all the three hydrogen atoms are replaced by 3 nitro group, and thus in this reaction all the three hydrogens are replaced by 3 nitro group, and this particular compound is called as the glyceryl trinitrate किंवा त्याला आपण नायट्रोग्लिसरीन असे म्हणतो आहोत. ग्लिसरीन ट्रायनायट्रेट or nitroglycerin. This is a very, very important compound, nitroglycerin. Yes, it is used as an explosive. तो explosive मध्ये खूप मोठ्या प्रमाणात यूज केला जातो. Here, that nitroglycerin also used in dynamite. म्हणजे कन्स्ट्रक्टिव्ह आणि डिस्ट्रक्टिव्ह दोन्ही पर्पज मध्ये या नायट्रोग्लिसरीनचा एक्सप्लोजिव्हचा यूज केला जातोय. ओके, नाउ लेट अस सी नेक्स्ट रिएक्शन विथ पोटॅशियम हायड्रोजन सल्फेट. Potassium hydrogen sulfate is the example of dehydrating agent, K₂SO4. This is the potassium hydrogen sulfate. Now let us see our glycerol. When it reacted with that potassium hydrogen sulfate, what happens here? It undergo dehydration. Dehydration means there is a loss of water molecule. In this reaction, there is a loss of 2 water molecules. 2 water molecules त्यामधून बाहेर पडतात. This OH and hydrogen atom from the adjacent carbon. इथला hydrogen H2O बाहेर पडेल. या 2 कार्बनच्या मध्ये डबल बॉन्ड येतो. Similarly, this OH and hydrogen atom from the adjacent, and thus there is a loss of two water molecules, आणि इथं दोन्ही कार्बनच्या मध्ये डबल बॉन्ड येतात, and we get the compound. But this compound is quite unstable. It undergo tautomerism. त्याचं tautomerism होतं. tautomerism म्हणजे कसं होईल बघा. हा जो हायड्रोजन आहे, दिस हायड्रोजन गोज टुवर्ड्स कार्बन, तो कार्बन कडे जातो, आणि इथला जो डबल बॉन्ड आहे तो डबल बॉन्ड इथं येतो, and there is a formation of such compound CH2 double bond CH and CHO means this is aldehyde group. Now there is a formation of aldehyde group, and this is stable one, and that compound is called acrylaldehyde, or it is also known as acrolein, and it having very ugly smell actually. खूप तर this compound can be prepared by using glycerol. Glycerolचं आपण जर डिहायड्रेशन केलं by using potassium hydrogen sulfate, there is a loss of 2 water molecule, आणि आपल्याला त्यापासून मिळतोय ॲक्रिलाल्डिहाइड किंवा ॲक्रोलीन. ओके, दिस इज रिएक्शन नंबर 4 ऍक्च्युअली, हाऊ दॅट ग्लिसरॉल अंडरगो डिहायड्रेशन. नाउ लेट अस सी वन मोर रिएक्शन, एस्टरिफिकेशन. Okay, formation of ester actually. When glycerol is treated with the acetic acid, glycerol ची reaction जर आपण acetic acid बरोबर केला at high temperature and we get the product बघा OCOCS3, 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 and this is the triester actually, and that reaction is called esterification. Means glycerol on reaction with any carboxylic acid and there is the formation of corresponding ester, and आपल्याला जो मिळतो final compound, that compound is nothing but the ester, and that reaction is called esterification. Name of the particular compound is a glyceryl triacetate. Glyceryl triacetate. Okay, this is just about the esterification of glycerol. We can carry out the esterification of glycerol by using any carboxylic acid. Generally, that reactions are carried out at high temperature and also maybe in presence of some strong acid also. Let us see next one, oxidation with dilute nitric acid. Let us see some oxidation reactions of that glycerol. First one is the dilute nitric acid. When that glycerol is created with the dilute nitric acid, yes, it undergo oxidation. Now, what is the general trend for the oxidation of alcohol? Any alcohol, general trend for the oxidation of alcohol. Primary alcohol on oxidation gives aldehyde, which on further oxidation gives carboxylic acid. Secondary alcohol on oxidation gives ketone, which on further oxidation gives carboxylic acid. ओके, दिस इज द जनरल ट्रेंड. मग आता इथं आपल्याकडे प्रायमरी आणि सेकंडरी दोन्ही OH ग्रुप आहे. मग नायट्रिक ऍसिडचं काय रिएक्शन होते, हाऊ दॅट डायल्यूट नायट्रिक ऍसिड कॉजेस ऑक्सिडेशन ऑफ दॅट ग्लिसरॉल, हे आपण यामध्ये बघणार आहोत. फर्स्ट स्टेप मध्ये काय होतं बघा, हिअर वन ऑफ द प्रायमरी OH ग्रुप, ऍक्च्युअली प्रायमरी OH ग्रुप इज द मोर रिएक्टिव्ह and therefore it easily undergo oxidation, त्याचं ऑक्सिडेशन होतं. and here the CH2OH group convert into CHO, त्याचं कन्व्हर्जन डायरेक्टली CHO मध्ये होतं अल्डिहाइड मध्ये. Primary OH group convert into aldehyde when glycerol is created with dilute nitric acid in first step, and that primary OH group converts into CHO and we get the corresponding aldehyde, and this is called glyceraldehyde. Name of the compound is the glyceraldehyde first step. Now this glyceraldehyde further undergo reaction, त्याची पुन्हा रिएक्शन होते and that CHO group converts into COOH. This is the general trend. Aldehyde further undergo oxidation and converts into the COOH carboxylic group, and this is glyceric acid. That glyceric acid again undergo oxidation. यामध्ये असणारा हा जो सेकंड प्रायमरी OH ग्रुप आहे, that second primary OH group it again undergo oxidation. याचं पुढच्या स्टेप मध्ये ऑक्सिडेशन होतं and it converts into CHO. त्याचं कन्व्हर्जन CHO मध्ये होतं, म्हणजे अल्डिहाइड ग्रुप मध्ये होता. Now this again undergo oxidation and that CHO also convert into carboxylic group. त्याचं कन्व्हर्जन कार्बोक्सिलिक ग्रुप मध्ये होतं and we get the dicarboxylic acid. This compound having two COOH group. Okay, and the name of compound is the tartronic acid. या कंपाऊंडचं नाव आहे tartronic acid. By using dilute nitric acid, we causes oxidation of glycerol into tartronic acid as a final product. In this reaction, only two primary OH group undergo oxidation, one after other. Secondary OH group do not affected. It do not undergo oxidation by using dilute nitric acid. Only two primary OH group undergo oxidation. In first step, that primary OH group, first primary OH group undergo oxidation to form aldehyde. It further undergo oxidation to form carboxylic acid, that is glyceric acid. In second step, another primary OH group undergo oxidation, we get aldehyde, and it again undergo oxidation and we get the dicarboxylic acid, that is tartronic acid. Thus, that two primary OH group undergo oxidation one after other to form corresponding tartronic acid. This is just about the oxidation by using dilute nitric acid. Okay, now let us see one more reaction, oxidation with Fanton's reagent. Fanton's reagent. Now, what is the Fanton's reagent? किंवा bromine water आपण यूज करतोय in the same case. Suppose this is our glycerol. When it reacted with the mixture of hydrogen peroxide and ferrous sulfate. Hydrogen peroxide and ferrous sulfate, that mixture is called Fanton's reagent, or we can use bromine water also. Same type of reaction is there. Now, what happens here? Here, that primary OH group may be undergo oxidation. पहिल्या स्टेप मध्ये या प्रायमरी CH2OH ऑक्सिडेशन होतं. It converts into CHO. We get the glyceric acid. Now there is one more possibility. यामध्ये आणखीन एक पॉसिबिलिटी काय आहे? सेकंडरी OH ग्रुप कॅन बी अंडरगो ऑक्सिडेशन. सेकंडरी OH चं सुद्धा ऑक्सिडेशन होतं. मग सेकंडरी OH चं कन्व्हर्जन कशामध्ये होईल? Obviously, secondary OH group converts into ketone when glycerol is treated with the Fanton's reagent or bromine water. There are two possibilities. Primary OH group can be converts into CHO, or secondary OH group can be converts into ketone, and we get the mixture of two products. This compound is the dihydroxyacetone. There is a mixture of glyceraldehyde and dihydroxyacetone, and this is the second method, oxidation method. Then let us see one more method by using acidified KMnO4. Here what happens? Suppose we are using the acidified KMnO4. In first step, both the primary OH group directly undergo oxidation. दोन्ही primary OH group चं oxidation होतं, and that primary OH group converts into CHO. दोन्हीचंही conversion मी CHO मध्ये दाखवतोय. There is a formation of such dihaldehyde compound. It further undergo oxidation. त्याचं पुन्हा oxidation होतं. Both the CHO group converts into COOH. दोन्ही CHO चं conversion COOH होतं. That secondary OH group also undergo oxidation because acidified KMnO4 is a strong oxidizing agent. म्हणून पहिल्या स्टेप मध्ये दोन्ही प्रायमरी OH ग्रुपचं ऑक्सिडेशन होतं अल्डिहाइड मध्ये. सेकंड स्टेप मध्ये सेकंडरी OH ग्रुपचं ऑक्सिडेशन होतं कार्बोनिल ग्रुप मध्ये, कीटोन मध्ये. अँड अलॉंग विथ दॅट बोथ द अल्डिहाइड ग्रुप ऑल्सो कन्वर्ट्स इनटू COOH. त्याचंही कन्वर्जन COOH मध्ये होतं. नाउ इट ऑन फर्दर ऑक्सिडेशन. त्याचं जर मी पुन्हा ऑक्सिडेशन केलं तर पुढच्या स्टेप मध्ये काय पॉसिबिलिटी आहे बघा. इट ऑन फर्दर ऑक्सिडेशन. त्याचं पुन्हा ऑक्सिडेशन केलं तर यामधून काय होतं? हा CO बाहेर पडतो. हा CO आणि हा नेसंट ऑक्सिजन, ओके, यापासून तयार होतं CO2 कार्बन डायऑक्साईड आणि तो बाहेर पडतो. मग दोन COOH मध्ये बॉन्ड आहे, दोन COOH. दिस इज नथिंग बट ऑक्झॅलिक ऍसिड. त्याला आपण ऑक्झॅलिक ऍसिड असं म्हणतो. Thus there is a loss of carbon dioxide and we get oxalic acid. It further react with the nascent oxygen. त्याचं पुन्हा ऑक्सिडेशन होतं. इथंही हा बॉन्ड ब्रेक होतो. मग यामधला एक हायड्रोजन, इथला एक हायड्रोजन आणि एक ऑक्सिजन H₂O तयार होतो आणि कार्बन डायऑक्साईडचे दोन मॉलिक्यूल. म्हणजे फायनली देर इज अ लॉस ऑफ कार्बन डायऑक्साईड. ओके, अँड thus by using strong oxidizing agent glycerol can be finally convert into carbon dioxide also as well as oxalic acid also. Okay, this is just about the oxidation of glycerol by using different oxidizing agent. यामध्ये तीन प्रकारचे एजंट पाहिलं आपण. First one is the dilute nitric acid, second Fanton's reagent किंवा bromine water, and third acidified KMnO4.